Alright guys, we are going to check out just the basics of solving right triangle trigonometry. We've been calling it SOHCAHTOA. So if you've been a little confused by it, let's just walk through it with the basics. When you take a triangle, a right triangle with a certain angle, if you're looking at the angle, I'm going to call it theta, that little angle symbol. Based on theta, there are three sides. Right? One side is across from the 90-degree angle. That's always the hypotenuse. Okay? Hypotenuse. Because he's the longest side, across from the 90-degree angle. The side that's across from the angle itself is called the opposite side. So this guy is the opposite side. And the side that is right next to the angle is called the adjacent side. Okay, we're just trying to name these. The hypotenuse is also next to this angle, except it's the longest one. We can tell because it's across from the 90-degree angle, and so therefore it reserves a special name, which is hypotenuse. Okay, so based on this angle, we have the opposite side, the adjacent side, and the longest side is the hypotenuse. Cool. If we looked at another triangle, that here's our 90-degree angle. If we were looking at this angle, right, if we're looking at that angle theta, across from the 90 is the hypotenuse. Across from the angle itself, you'll get the opposite side. And the one that's right next to the angle but isn't the hypotenuse is called the adjacent side. Okay? So you should be able to identify just the names of those angles in relation to the other bits. So let's take that idea and look at the basics of sine, cosine, and tangent. With sine, if you're talking about the sine of any angle, this is just the decimal that you get when you take the opposite side and divide by the hypotenuse. It's a decimal, and your calculator knows what those are. So if this was a 40-degree angle, you'd put into your calculator sine of 40, and I got out 0.642 as the decimal, right? And that should be the angle that you get when you divide the opposite by the hypotenuse. Okay, so now if we knew that the hypotenuse was 5, and we were looking for the opposite, you could say the opposite x, I don't know what that is, divided by 5 should give me that decimal. And then you can multiply both sides by 5. They cancel out of this side, and you'll be left with 5 times that decimal, which is 3.21, and that should be that length x. Okay, let's take that idea and try that first question in the homework. Okay, I'm going to try to grab this. Let's see. Oop. All right. Let's take this idea and I'm going to move this piece down, hopefully. Oop. Sorry, technical difficulties. So this angle is the one that we're talking about, and so there are 2 of the 3 sides are involved. This is the 90-degree angle, so the side across from that is the hypotenuse. And the side across from the angle itself, we're going to call the opposite. This one would be the adjacent, but since he's not part of the game, he's not the one we're looking for, and he's not the one that we have, so we're just going to ignore that one for now. We don't need that one. All we need is the names of the opposite and the hypotenuse. Okay, so we have the opposite, and the hypotenuse, and so that ratio, if we divide the opposite and the hypotenuse, that's going to be the sine. We're going to use the sine of 68. And we know it's sine because we're using this acronym SOHCAHTOA, and the sine is just the opposite divided by the hypotenuse. Sine is just the decimal. So if you plug in sine of 68 into your calculator, I got 0.927 equals the opposite over the hypotenuse is the ratio we get when we divide the opposite and the hypotenuse. I don't know the opposite. It's called x, so I'm going to put in x, but I do know the hypotenuse. It's 19. So let's multiply both sides by 19. They cancel out of this side, we're just left with x, and on this side we're left with 17.6. Cool. Okay, so there's sine. Let's look at this one. This is our angle, 27. This side is across from the 90-degree angle, so this is the hypotenuse. This side is across from the 27-degree angle that we're interested in, and so this should be the opposite. But we can't use sine because we don't know this side. We're looking for this side, and this side is next to the angle but not the hypotenuse, so this side is called the adjacent. So we're looking at the adjacent, and we know if we take the adjacent and divide by the hypotenuse, we'll get a special decimal, and that decimal is the cosine of 27. And we remember that from this part, the cosine is the adjacent over the hypotenuse. The adjacent over the hypotenuse, we know that we'll use cosine here. Right? So cosine is adjacent over hypotenuse. We use the mnemonic device to help us remember that cosine is adjacent over hypotenuse. When you plug in cosine of 27, you get this decimal, and the adjacent side is x. I don't know what that is, but the hypotenuse is 10. So I've got decimal equals x over 10. I want to get rid of the 10, so multiply both sides by 10. These cancel out, and we're left with x is 8.91. Cool? Great. In that last one, here's the angle, 54. We have the hypotenuse over here, but we're not interested in the hypotenuse. We're interested in these two sides. This side is called the opposite because it's opposite the 54-degree angle. And this side is called the adjacent because it's next to the angle, but it's not the hypotenuse. The hypotenuse gets its own name. It's a special piece. So I know that there will be a special ratio if you take the opposite and divide by the adjacent. There's a special ratio that we call the tangent. So if we take any 54-degree triangle, we divide by the opposite and the adjacent, we'll get a special decimal. We remember that because the tangent that is the opposite over the adjacent. The tangent is the one we want because in SOHCAHTOA, it's just a mnemonic device that helps us remember that the tangent is the opposite over the adjacent, right? The tangent is the opposite over the adjacent. So we ask our calculator for the tangent of 54, and it gives us the decimal 1.376. The opposite, I don't know, we're going to call x, and the adjacent, I do know, it's 4.82. So then we want to get x by itself, multiply both sides by 4.82. These cancel, and you're left with x is equal to 6.63. All right, so let's look at D. I don't have it put in here, but I'll draw it out. In D, we have a triangle that looks like that and like that. Oh, let's make that straight. They said that this is x and this is 39 and this is 12.96. Here's the right angle. So the two sides that we have working with is across from the 90, so this is the hypotenuse. And this is the adjacent side. It's next to the angle, so adjacent. So we're looking at A and H. We think about so, ka, toa, and the A and the H only come into the ka part. So we know that we're going to use cosine of that angle. Should be the decimal we get when we divide the adjacent by the hypotenuse. All right. So cosine of 39 is 0.77. The adjacent is 12.98 or 6, and the hypotenuse is x. The only difficulty here is the x is in the denominator. So multiply both sides by x so they cancel. You get 12.96 equals 0.77x. And then to get rid of the 0.77, divide by 0.77 on both sides. These cancel out of here, and you're left with x is 12.96 divided by that answer. We should get 16.67. Cool? All right, try that out.